What is CNC machining and how it works? Precision manufacturing plays a vital role in our modern world, from the intricate parts of the spacecraft to the juice and high-performance cast parts. CNC machining has provided a means for high accuracy and reliability. Welcome back to Honpe Prototyping's channel today. We will delve into the world of CNC machining, exploring its basics and getting a deeper understanding of how it works. Join us to get insights. Let's start by understanding what is CNC machining. Machining is CNC stands for Computer Numerical Control. The manufacturing process uses computerized controls to operate machinery and pressure straight raw material into finished parts. Unlike 3D printing, which is an additive manufacturing process, CNC machining is a subtraction manufacturing technique. In other words, it removes material from a solid block to create a desired shape. As CNC machining work, the process begins with a computer-aided design CAD view, which serves as the blueprint for the desired parts. This view contains all the dimensions and specifications required for machining. The next step involves programming the CNC machine here. The CAD view is converted into machine-readable instructions. Once the program is set, the CNC machine is ready for operation. The machine operator loads the raw material onto the machine's work table. The CNC machine then positions the cutting tool pressure and starts removing material according to the programming instructions. This process continues until the desired shape is achieved. You can check out the CNC machining process video on our channel to better understanding this technique. There are two primary types of CNC machining operations. They are CNC milling and CNC turning. CNC milling involves rotating the cutting tool while moving it along multiple axes. This allows for complex shapes and contours. On the other hand, CNC turning rotates the workpiece while the cutting tool shapes it. This operation is mainly used for cylindrical parts like shafts and threaded components. CNC machines come in various configurations to accommodate different manufacturing needs. A good look at some common types first. We have three kinds of CNC machines. These machines move the cutting tool along three axes, typically X, Y, and Z. They are suitable for simple parts with less complex geometries. There are also four-axis CNC machines, in addition to the three linear axes. These machines can rotate the workpiece on a fourth axis. This rotational movement enables the machining of more intricate features and curved surfaces. Five-axis CNC machines are advanced options that offer even greater flexibility by adding two rotational axes. This allows for machining highly complex shapes and controls for multiple angles lasting mill. Turning CNC machines combine the capability of both milling and turning operations. These machines offer a versatile solution for manufacturing parts with both cylindrical and intricate features. Now that we understand how CNC machining works, is why it's such a popular choice for precision manufacturing. One significant advantage is the high level of precision. It offers CNC machines can achieve incredibly tight load tolerance, ensuring parts are produced with accuracy and constancy. Standard tolerance in CNC machining are typically around plus minus and 0.125 mm, which is already impressive. However, tighter tolerance of plus minus and 0.05 mm and even high precision tolerance of plus minus and 0.01 millimeter can be achieved for more demanding applications. Another key benefit is the automation driving nature of CNC machining. Once the machine is set up and programming, it can operate continuously with minimal human intervention. This automation results in quicker turnaround times and ensures high standard of constant throughout the production process. Moreover, CNC machining is ideal for working with a wide range of materials. CNC machines can handle metals like aluminum, steel, and bronze, as well as plastics like ABS and nylon. This versatility makes CNC machining a top choice for industries requiring parts for different materials. Speaking of industries, CNC machining finds applications in various sectors. Let's explore some of them. In the aerospace industry, CNC machining is crucial for manufacturing precise and lightweight components for aircraft and spacecraft. CNC machining ensures the high heat security and performance from turbine blades to structural elements. Automotive industry heavily relies on CNC machining for producing engine components, transmission parts, and intricate assemblies. CNC machines enable the creation of complex shapes and tight tolerance required for reliable and efficient automotive systems. In the medical field, CNC machining is essential for manufacturing surgical instruments, prosthetics, and medical device components. The precision and accuracy of CNC machining ensure the safety and effectiveness of these critical medical tools. The consumer goods industries benefits from CNC machining, from high-end watches to electronic devices. CNC machining enables the production of finely quality and precisely engineered products that enhance our daily lives to showcase the capability of CNC machining. Now let's take a look at some samples at Honpe Prototyping showroom. CNC machining parts. CNC machining plays a pivotal role in bringing these parts to life. In conclusion, CNC machining is a cornerstone of precision manufacturing. It has the ability to deliver high precision automation driving processes and versatility in working with various materials. This makes it an invaluable technical across many industries. We hope this video has provided you with a solid understanding of CNC machining basics, its advantages, and its applications. Thank you for joining us on this insightful CNC machining video. Kindly subscribe to our channel and stay tuned for more exciting content for Honpe Prototyping. See you in the next video.